session, we discussed about some of the classification techniques, and we saw the implementation in Python using scikit-learn. So we'll come back to some of the issues with classification and what are those issues, what are the points that we have to remember when we classify. Okay, later on. Today we will cover some basics of clustering. That is again another kind of machine learning technique. It is different from classification. Okay, but it is mostly used as a pre-processing step, but it's also on its own also it's important. Okay, and so we'll cover a few clustering techniques, at least two of them, in different sessions. So today we'll cover the k-means, which is on the basic clustering technique. Okay, but before that, let's understand what clustering means. So the basic idea of clustering, as you can see here, is to divide data into similar groups. Okay, so similar groups means the groups which have some kind of similarity with each other. Okay, they should be grouped together with other similar objects. Okay, or you can say similar objects having certain similar properties should be grouped together. Okay, and one group must have some differentiating quality about it from other groups, or you can say the members of one group should have some quality that makes them different from other group. Okay, so each group here is called a cluster. So if you have 100 members or 100 data points or 100 examples, samples, whatever they call it, and let's say you want to divide them into, let's say you know that there are total of say 5 clusters that these 100 examples fall into. Okay, and then maybe there are different number of examples in each cluster. Okay, but once you form those 5 clusters, they will, each of the 5 clusters will have some difference from other cluster. Okay, it will have something that makes it different from other clusters. Okay, and it also has something that makes it similar to members of its own group. Okay, or you can say the members of a cluster has some similarity with each other. Okay, there's a query. When will be the last class? Our exam starts on May 3, so completing early will help to revise and study. Yeah. So today is 23rd. Okay, so we'll finish 23rd today. That means, yeah, tomorrow also we have class. So 25 contract hours will be over tomorrow, right? So 25, that means after that you have 5 or 6 remaining. Out of that, last will be revision. So you can say 4 or 5, right? So that means 2 more weeks for finishing the syllabus. So 2 more weeks would be like not even 2 more weeks, 1 week, because we'll have 4-hour session in a week, right? So 2 plus 2. So next week you'll have almost everything done by next Sunday. That is not tomorrow, after that, right? Almost everything will be finished. Okay, so it's 14th the holiday. If 14th is holiday, then next Sunday after that. Okay, that means 21st. So we'll have time for that, for studying. Okay. Anyway, so we'll finish much before yours. Okay. About regarding the quiz, I'll upload it because I'm waiting for. You have to do one quiz and assignment. Okay. So you'll get ample time for assignment. For quiz, I'm just waiting for this part to be over so that I can give some questions on clustering also. Okay. So we'll cover some part of the clustering and then I'll float the quiz. Okay. And once we finish with clustering, you'll also get the assignment, that is the coding part. Okay. So there are 2 quizzes and 1 assignment, isn't it? According to your handout. Okay. Okay, let's come back to the topic. So what is the goal of clustering analysis? Here, as you can see, there are 2 main part where clustering analysis is important. One is to understand data. Okay, when you just want to understand data in itself. Okay, so for example, information retrieval or climate study. So for example, you want to study, say, you want to find out, say, what are the regions, okay, that have certain specific climate. Okay, so then you find out the properties. You have all the different properties of all the regions, and then you try to cluster them together, or to cluster them into different regions. Okay. So maybe based upon the vegetation, based upon the kind of flora and fauna that are found, okay. Or maybe you want to cluster different countries of the world depending upon certain maybe economic or socio-economic properties of those countries. Okay. So that way you just get an idea about the different countries in the world, which are developed country, which are undeveloped country, underdeveloped, okay, which are developing countries. So you can just group them to different regions, maybe per capita income or poverty, education level. All these things are different factors which can be used to cluster different countries or different regions of the world or different continents. Okay. So that is understanding data. You just want to understand how the data, how the world, or how different regions of the world are compared to each other. Okay, or what are the similarities? Okay, and then just by looking at it, maybe you'll get some insight. Maybe you'll find that okay, countries in this particular region are underdeveloped. Okay, or countries in that particular region are highly developed, and then you try to understand why is it so. It could be just, it's a very basic example. It could be that reason. So you want to understand data. Maybe it is economical data, some other socio-economical data, or some other data. Okay, or even let's say for example in India, you may want to group or you want to cluster different regions depending upon the education level. Okay, you just want to form clusters of educational or the level of education. Okay, so again, by looking at such clusters, you'll try to get some idea about where to focus upon. Okay, so the government, for example, does a lot of clustering like that, so that it finds out, so just that you can find out what needs to be done, what kind of policies should be created or should be initiated, or what kind of schemes should be initiated. Maybe it is electrification, education, or sanitation, whatever. So that is for understanding data and to make some certain decisions. Then it can be used as a utility itself. It can be used as a part of doing something else, but it can be an initial pre-processing step that I told earlier. So for example, in summarization, so summarization is like, say for example, there is a lot of text, okay, and you want to summarize, say, the text into, let's say you want to just find out different news items which are coming from all the text. For example, let's say you may have, let's say, a lot of Facebook data, a lot of Twitter data, okay, and then you want to cluster those data into, say, different kind of news and non-news. Okay, so that those clusters which are formed will be either related to news or not related to news. Now you don't have any idea which. So here the difference between clustering and classification is it is unsupervised. Okay. Clustering is unsupervised, so you don't have any label to the data. So you have all the, let's say, all the Facebook messages or Twitter messages, and then the algorithm, the clustering algorithm, will just look at all the properties, maybe the data, all the different bag of words matrices, and try to find out what are the similar grouping of data, so that one it can form clusters of different kind of news or non-news. Okay, and then once you have got the clusters, then you would, next step would be to summarize that data, summarize that cluster. Okay, so cluster of certain news, let's say sports news about something. Okay, let's say you have got 1000 tweets about certain sporting event. Okay, that so the clustering has been able to form a cluster about some sporting messages, or you can say messages about certain sporting event. Okay, but then the main goal is here is to summarize that and then present it maybe to a user, to users. So you will present to the user final summarized news item, some headline in some headline form out of all these tweets. Okay. So here clustering has been applied as a pre-processing step. You just clustered all the different group of items together. Okay, or different news items. You cluster them into different clusters. Let's say you have 8 clusters of different kinds, sports, politics, like this, and then you just put each tweet into one of these clusters. Okay, and then finally summarize that. So that is example of clustering as a utility. Here you have used cluster as a tool to summarize data. So final goal was to summarize data. Clustering has been used as a utility. Okay, so there are different examples where you see that clustering is used either as a utility or as a means to understand data itself. So the unsupervised method, that is cluster analysis or clustering, one of the basic algorithms in this, one of the most popular but very basic and very easy to understand and analyze, is called k-means clustering. Okay, any questions? So let's discuss about the k-means clustering algorithm, which is very simple and easy to understand. Okay, so k-means, it means k here is the number of clusters. Okay, so k-means here is the centroid. Okay, it's kind of mean of, or you can say average of all the groups into a centroid. So each cluster has its centroid. So if you have k clusters, you'll have k centroids or k means. So that is called k means algorithm, because the ultimate goal is to find k such means which will have some property. Okay, or you can say it has some property such that each example in a cluster, after you have formed the clustering by using k means, each example is nearest to the centroid or to the mean of its cluster. Okay, so if you have, say, cluster number 1, and all the examples in that cluster will be nearest to that only. Okay. In a different cluster, the corresponding or the containing elements or containing examples in that cluster number, say number 2, will be nearest to that cluster. Okay, so your ultimate goal is to find or to put each example or each sample to one cluster, and then that will minimize the distance of that particular, of each example from the centroid or from the means. So the steps to, so we'll look into detail of this algorithm, but let's just look at what it means. So initially you just randomly select k centroids. Okay, so k centroid, it could be among the examples. So k centroids can be selected from among the examples itself. So randomly select just 4 examples. Okay, don't select any continuous examples, or randomly select 4 of them or k of them. as initial centroids. Okay, or you can also sometimes it's also possible to just select say k regions and then calculate the 4 centroids. Okay, so just select 4 regions. Each region will have certain random points. Select centroid from there, or maybe just select 4 centroids from any data point, any random data point. But the basic thing here is to select, or the the simplest thing is to do is to select the k examples as initial k means, okay, or initial centroids, and those are random. Randomly select k examples as the initial centroids. So I'll call centroids instead of means so that it's not confusing. But centroids are actually means only. Yeah. So we'll look into multidimensional data also. Don't worry about that. Okay. So assign each object to the cluster with the nearest centroid. Now, once you have selected the the k means, k centroids, then each of the example will be put. So that k centroids you have selected means which are these are initially you have assumed that these are the 4 centers, 4 different centers, okay, or 4 different these represent the 4 k different regions. Okay, initially you have selected k different centroids. That means they are representative of k different regions, or they are centers of 4 different regions. Okay, so you try to then next step will be to try to assign each of the objects to one of those centroids depending upon which is nearest. Okay, so each example will go to the nearest centroid. Okay, so you'll just look at the distance of each example from the nearest, from each of the centroids, k centroids, and then assign it to the centroid which is nearest to it. So that is the second step. Okay, now once you have put all the examples, once you have assigned every example to one of the centroids, then you have got initial k clusters, right? So each of the k clusters now have the centroids that you have selected and remaining points which have been assigned to it. Once you have got that, then you'll again calculate the centroid. Okay, so compute centroid as the mean of the objects assigned to it. Okay, so again you will look at the samples which have been assigned to, let's say, cluster number 1. Okay, find their mean, or you can say, so that find again the centroid. New centroid is calculated. This is just a basic averaging. So once the centroid is calculated, now you've got a different centroid now, right? Because now you are recalculating the centroid based upon all the elements which have been assigned to it. So you are just finding the average of each feature or each dimension. So you're getting k different centroids now. So again you will repeat the earlier steps. Once you have got k centroids, again reassign the points to the nearest centroid. Okay. Once you reassign the point to nearest centroid, all the points are assigned. Again recalculate the centroid and repeat the same step. Okay. So you will repeat this step until a time comes when there is no more possibility of, or when the centroid is not changing, okay, or when a point is not moving across different clusters. Okay, when all the points are fixed, they are not changing their clusters. That means that the k-means algorithm is done. Stop there. Okay. And it doesn't matter how many dimensions the data has. We'll just use each dimension as a feature and just find the average of those features to calculate the centroid. Okay. So the question was, is the data can be multidimensional? If yes, on what basis we can select in multidimensional? So multidimensional here means, let's say you have more than 2 features. So features will be say 1, 5, 6. Let's say this is first points feature, or you can let's say 4 features, 4 dimension, 1 5 6 7. Okay, and the second sample, so this sample 1, then there is sample 2 whose features are say 3, let's say 3 again, and let's say 2 1, and let's say these two belong to the same cluster. They have been assigned to the same cluster. So in that case, the average, the k-mean. So let's say cluster consists of only these two samples or these 2 points. So in that case, just look at the average of each. So there are 2 samples. Just average each feature. So here this is 2, 3 plus 1 by 2, 5 plus 3 by 2 is 4, 6 plus 2 by 2 is again 4, is again 4. So this will be your centroid. So the centroid will be 2 4 4 4. This will be your centroid. Is it clear? It doesn't matter how many dimensions you have. Okay, and the question is how many iterations are required to reach the end. Normally you'll see that it finishes quite fast. Okay, quite fast. Unless you have millions of data sets and a lot of clusters, it converges very fast. Okay, but you can actually limit the number of iterations. That's up to you. If you don't want to create exact clusters, you can limit the iterations also. In certain cases, you have this capability to finish after say 300 iterations or 200 iterations. It reaches their stop. Okay. Most tools have this capability. Many tools have this capability to stop k-means beyond certain iterations. Let me check whether the tool that we are using have this. Okay. K-means and SK. So for example, the k-means have the match iterations that you can set while calling k-means algorithm. Or k-mean, when creating that k-mean function, you can. So this is the k-means algorithm here, and you can see that max iter is equal to 300 by default. Is how many iterations you want to continue at most. Awesome. Okay, so it is not difficult to understand. It's very easy. Any doubt in this algorithm? Let's look at visually what happens here, and then we will look at small example with points, and then at the end we will also look at one of the implementation of iris dataset, k-means clustering in iris dataset that we have already used, right? So what is the iris dataset? So iris dataset is dataset of 3 different species of flowers, right? Sepals, and you have 4 features for each flower. So you have total of 150 samples, 150 examples. Each example has 4 features: sepal length, sepal width, petal length, petal width. And those 150 samples have been grouped, are actually taken from 3 different species of flowers, and 50 each. So 50 plus 50 plus 50, total 150 samples are there. Each sample has 4 features. Alright. So that will be using. So it's a very popular, one of the most popular data sets in machine learning in both classification and clustering. Okay. So let's look at this example of this visualization of one step of k-means clustering. So initially you have this cluster, these samples, okay, and let's say you have selected certain initial centroids, and after that allocated each point to which is nearest to the centroid, and you got this result. Okay, So this result is after you have allocated each point, or you have assigned each point to the nearest centroid. Okay. Alright. Now what happens is you now recalculate the centroid. So the second step, so this is the second step, that is recalculate the centroid. Okay. So these red dots are the new centroids. Okay. So the new centroid will not be among the points; it will be different, right? Because you are just averaging the features. So these red points are the new centroids for the two clusters. So once you have got new centroids and you see that, then you assign each point to the nearest centroid. Okay. So once you do that, you get these two. The third case, you get two clusters. You can see that one is light greenish and one is dark blue. So these are the two different clusters you have got after reassigning the point. You can see that the point here has been reassigned. This particular point was earlier this cluster, that green cluster. Now it has gone to blue cluster. Right. So it has gone to the other cluster now. Okay. And similarly, this point, dark blue point, was in blue cluster. It has gone to green cluster now. So the 2 points have changed their cluster. They have moved across. So that means you cannot finish now. It is not yet finished. Again, you repeat the process. So once each point has been reassigned, again recalculate the centroid. Okay. And that is happening here. So here, these red points are the two centroid after recalculation. Okay. And then you will repeat. Once you have got two centroids, again reassign the points to the nearest centroid and repeat until there is no change. Okay. So after this, maybe it stops because no further reassignment happens. Okay. So centroid, remember that centroid here is just a logical thing. Okay. What a cluster consists of basically is the points. Okay. Centroid is just the average of those points. Okay. So when a point moves from one cluster to another, obviously the centroid will also be recalculated because now the clusters have different number of points, so the centroid will change obviously. Okay. So centroid will change. Okay, there's a question. Bottom blue 5-1. Yes, that I explained. It was in the green cluster, and then you move to the blue cluster. Okay. So once the centroids are recalculated, then reassignment of the point happens. Okay, each point is again reassigned to one of the clusters, and they may change clusters after that. Okay, so every point will be reassigned. Reassigned means again it will recalculate, the distance to the nearest centroid is recalculated, and then each point will be assigned to the cluster centroid which is nearest to it. Okay, and if that centroid, because the centroid has changed, okay, it may happen that a point which is nearest to the earlier centroid now has changed. It will go to some other centroid. Okay, so if this doesn't happen, that means now they are perfectly fine. You have built the perfect cluster. But if some point changes its cluster because of reassignment of centroid, then you have to repeat the process again. Again, calculate centroid, reassign. Okay. Yes. So after every point moves, centroid changes. So I'm calling point, but just a data point. Okay, it could be, it's not like point in 2 dimensions. It's an example, a sample. Okay, it can be multi-dimensional with multiple features. Okay, let's look at a concrete example with a 2-dimensional kind of coordinates. so that it is easy to calculate, right? So let's see, we have this data set. Okay, there's a question in decision tree. Every time we get different as seed is not fixed. Okay, in decision tree, you can actually fix random state, right? If you fix random state to some number, so as long as you are using the same number every time, you get the same. So here also, yes, whenever you have random selection kind of, whenever you have to use random number, then there's always some random state that you can fix. In k-means also you have a random state. We will come to that. So I think in that k-means, I gave you one, the structure of k-means, right? How it looks like, how the function looks like. So you can see random state is equal to none by default, but you can set it to any number. Random state is equal to 42 or 0 or 10 to select the same set of centroids so that you get the same, start from the same random number, the same centroids, and you'll get the same endpoints, or the last clusters which will be built, or the k cluster which will be built will be same. So random state is also here. Okay. So in most of the examples, you'll see that there's a random state. There's some seeding you can do so that you can repeat your experiment later on. Reproduction of, or you can reproduce the experiments that you conduct at any time. All right. So this is a very toy example. It's just for learning. So you have 7 samples. Okay, each sample has 2 features, variable 1 and variable 2. So for example, sample 1 has features 1, 1, sample 2 has 1.5, 2, and so on. Okay, and here we want to create 2 clusters by using k-means. K is equal to 2 is given. Okay, so that means you want to group these numbers into 2 clusters. Okay, and let's say randomly you selected, say, point number 1 and point number 4, number 1 and number 4 as the initial centroids. It's randomly you can select. Okay, one thing that you should remember here is that the k-mean algorithm, depending upon the initial points chosen, it may give different results. Okay, so that's kind of one of the disadvantage of k-means, that depending upon the initial centroids chosen, okay, it may give a very good clustering or maybe very bad clustering. Okay, so there are actually updates on k-means, like k-means plus plus and so on, which are specifically to select initial centroids. Okay, so those algorithms have been created, those methods have been created especially for this part, the initial centroid selection. So there are research papers just on how to select the initial k centroids so that you get good clustering. Okay, or so that the probability of getting good clustering is maximized. Okay, but assuming that we don't have problems right now, okay, let's say randomly you are selecting centroids and it's fine, you'll get good clusters, or reasonably good clustering. So we will not go into that part, but remember that it is possible to get very bad clustering. So there are updated versions of k-means, okay, which take care of that. So assuming that we have that available to us, we are using good initial centroids. Yeah, so these initial centroids should be far from each other. That's good point. Okay. So here we have only 2 points, so just let's select them far away from each other. Alright. So here we have point number 1 and point number 4 as the initial 2 centroids. Now what is the second step? After this, what should you do? What should you do? So the initial centroid M1 is 1, 1, and second centroid is M2, 5, 7. These 2, right? What is the next step that you should do? then you have to assign each of the point to one of the clusters. Okay, so obviously the cluster, the point which is itself the centroid will be assigned to itself only because the distance is 0 to itself. But about the remaining points, let's say point number 2. Now you have to find to which cluster it is nearest to, whether to cluster 1 or cluster 2, to which cluster it is nearest, cluster 1 or cluster 2. Can you find out? Okay, so find the distance of point number 2 from the first centroid, that is M1 and M2. Let's do that. You can see the distance of the first point from the from M1 is 1.12, and from the second centroid it is 6.10. So obviously it is closer to first centroid M1. So the second point is assigned to cluster number 1. Okay, so 2 has gone to 1, and then similarly you do for the third point, fourth, okay, sixth and seventh. Sorry, fourth is already the centroid, so fifth, sixth, seventh. So repeat for each other points which are not centroid and look at which is nearest to that. Okay, so here this have been computed, and this is the matrix of the distances. Okay, so you can see here that point number 1, point number 2, and point number 3 have been put to first centroid. Okay, so his point number 3 had the same distance from 1 and 2, 3.61. So you can put it to either of the cluster. Okay, you may just have some simple rule to put into one of the clusters. So let's put it into the first cluster. Okay, so point number 1, 2, 3 have gone to cluster 1, and point number 4, 5, 6, 7 have gone to second cluster. Okay, because they were nearest to the second cluster. You can see, for example, distance of point number 7, the last point, from cluster 1 was 4.3, whereas from cluster 2 it is 2.9. So it is nearest to the second cluster, M2. Okay, so 4, 5, 6, 7 have gone to second cluster, 1, 2, 3 have gone to first cluster. Okay. So once you have assigned the points to one of the clusters, all the points have been assigned. Now you will recalculate the centroids. So just find the average of each feature. Okay, just calculate the average of each dimension of each feature. So for 1, 2, 3, point number 1, 2, 3, these are the first variable or first feature and second feature. First feature, second feature. So what is the average of the first feature? 1 plus 1.5 plus 3 by 2. Okay. Oh, sorry, 3 by 3. Now we have three points, so average will be by 3. So this is the first feature of the centroid. Okay, and then the second feature of the centroid will be again average of the second features of the 3 points which are in the first cluster. So it is 1.83 and 2.33. So up to here is clear? Any doubt up to here? So what you are doing is you are recalculating the centroid. Okay, just get the first centroid has 3 examples, 3 samples. The first cluster has 3 samples, and each sample has 2 features. So just finding the average of each feature. 0.1, 0.2, 0.3, 3 features. So P1 has first feature say F1, second and F2, And similarly for P2 and P3, so just average of F1 and average of F2. Okay, there's a question, how you divided the cluster. Okay, I've been explaining that. Maybe you are not paying attention. Let me again repeat how you divide the cluster, or how you create the cluster. Actually, we are not dividing, we are just we are assigning each point to the nearest centroid. Okay, so initial centroid was randomly selected as 0.1 and 0.4. Okay, so 0.1 was the first centroid and 0.4 was the second centroid. And then what he did was he calculated the distance of each point to these centroids. So first centroid, let's say it is C1 or M1. Second centroid was M2. Okay, so you have total 7 points. So find the difference of each of the points from M1 and M2 both. Okay, and each point will go to the nearest centroid, or to assign to that cluster, because centroid represents a cluster. So the second point here, the distance from the first M1 is 1.12 and distance from M2 is 6.1110. Okay, so the nearest centroid here is 1.12, right? Distance is minimum, so point 2 will be assigned to M1, or you can say cluster 1. Okay. If M1 represents cluster 1, M2 represents cluster 2. Okay, and similarly 3 will be assigned to either one. So 3 can be assigned to either one. So just put it to first one. Okay, so each point is assigned to one of the clusters. So you can see that 1, 2, 3 are nearest to centroid 1, and 4, 5, 6, 7 were nearest to centroid 2. The distance. Yeah, if you can find out which is the most suitable initial centroid, you can select it. That's not a problem, but you have to first find out. Okay, you should have a reason to do that. If you can do that, it's fine. Okay, you can select your own. Okay, but it is not easy, so it's better to just select two far away points as to centroids. Okay, so is it clear how the cluster is divided, or how you are creating the cluster? Cluster creation, someone asked me the question, so is that part clear? Okay. Okay, so once each point has been assigned to a cluster, that means two clusters have been formed now. Okay, now you recalculate the centroid of each cluster. Okay, so centroid of the first cluster will be average of the two features. So the first cluster has 3 points, first, second, and third. Okay, so first, second, and third. So average of the first 3 and average of the first variable for the first 3 points, and average of the second variable for the first 3 points. So first 3 points are first cluster, remember. So you are just calculating the centroid, that is the average or mean. Okay, so once you calculate the mean, you got new centroids 1.83, 2.33. This is the first centroid. The second centroid is 4.12, 5.38. Right, two centroids have been created, and you can see that these are different from the initial centroid. Okay, now once you have calculated this, once you have found out the new centroids, again you repeat, again you look at each point and see which centroid it is nearest, okay, and assign it to that particular centroid or that particular cluster. Centroid means cluster. So assign it to that particular cluster which is nearest to it. Okay, so after this step, what happens is you get the first 2 points nearest to the first cluster, and the 0.3, 4, 5, 6, 7, you'll see they are nearest to the second cluster. Okay, now you can see that point number 3 has now moved from the first cluster to second cluster. Okay, so again you can see that there has been some change, right? So whenever there is some change, that is whenever any single point, even a single point is moving from one cluster to another cluster, that means you have to repeat. So because here point number 3 has moved from cluster 1 to cluster 2, that means you can have to stop here, repeat. So repeat until there is no change. So again repeat, again recalculate the centroid and reassign. So when you recalculate centroid here at this point, you get these 2 points as centroid, that is 1.25 and 3.9 5.1. So these are the 2 centroids. Okay. Now when you reassign, you will see that none of the points is moving. Now all the points remain in their own cluster. That is, they are nearest to their own cluster. So they are not moving across. So at that point of time, you stop. Okay. So you see that after reassigning, you're getting the same cluster. So cluster 1 again is 1, 2. Cluster 2 is 3, 4, 5, 6, 7. Same thing. So you stop there. There is no change in the cluster. So whenever after one step there is no change in the cluster, you stop. Okay. So finally, you get 2 clusters. The first cluster contains 0.12, 1 and 2, and the second cluster contains 0.3, 4, 5, 6, 7. Okay, there's a question here. Somehow upper values in one cluster and bottom in other cluster. No process, no pre-processing here. Okay, there is no need of any pre-processing, and it is not actually so. You can see that some points are not like that. For example, in X case. Okay, yeah. So in this case, it's very strong example. So we have kind of sorted data, okay, but it is not necessary. Okay, because ultimately you have to reassign each point to the nearest centroid. So even if 0.2 was here and 0.7 was here, it won't make any difference, right? Even if you change 0.2 and 0.7, it won't matter because reassignment will happen. So whether it is 0.2 or 0.7 is not making any change. So why? So the ordering doesn't change. It doesn't matter. Okay. Any questions? You can see it's very simple. K means is very simple, right? So what do you think? How should the cluster be? What is the metric to see how good a clustering is? Now in classification, you have you have labels, right? You have labels, and you can compare against the label. You can predict. You can compare the predicted labels against the actual labels. What can you do with clustering? How can you measure how good the clustering is? Because there is no label. It is unsupervised. Right? There is no label. There are only data points. And you are given here, for example, you are given K, no, nothing else. So how can you measure? Think about something that can be used in such cases to measure the goodness of the clustering, how good the clustering is. Okay, so there's some answers. There are some answers. I will repeat here. So one answer is I'm getting these answers from you only, so I'll just read them out. Okay, so distance between two clusters should be maximum. Good. And distance between centroids. So what is distance between centroids? How does it matter? So that's a good point. Distance between two clusters should be maximum. distance between two clusters means distance to center, right? It's maximum. Okay. Okay. Anyway, so in this case, you'll see that these are the data points. If you just draw them out in 2D, okay, and this is how the clustering has been done. So you can see that is reasonably good clustering that has been done. Right? Point 1 and 2 are nearest to each other, and the remaining 5 points are quite near to each other. Okay, so we will continue with the matrix. Okay, how to measure the goodness of clustering after a short break.